Hello, Assalamualaikum everyone. Welcome back to Introduction to Electrical Power System. Chapter 2, Per Unit Quantities. So power transmission lines are operated at voltage level where the kilovolt is the most convenient unit to express voltage. Okay, as you all know, in power system, there's a large power being transmitted. It can be in kilowatts, megawatts, So this quantity as well as amperes and ohms are often expressed as percentage or also known as per unit. So per unit is actually based on the reference value. So for example, 1.00 is actually 100%. In per unit is 1.05, but in actual percentage is 105. So per unit is actually a ratio, where the actual divided by the base. If you want it to be in 100%, so you just have to times by 100. The advantage of using per unit quantities, it reduces the calculations, especially in three-phase system. And it's also more useful for digital computation. Here are the formula for per unit quantities. Per unit quantities is always actual quantity divided by the base quantity. So if you want to make it in percent, you just have to times it by 100. Let's do example 2.6. For example, you have a transmission system that's operating at 117,300 volt. So 117300 is actually the actual. So this is the actual. Alright. And with the nominal base rating of 11500. So this 115 is actually the base. How you know it's the base? Because in the question it says that nominal base rating at 11500. So the question asks you to calculate per unit voltage, and you know that the per unit is given by PU actual divided by base. So for example, A, how do you solve A and get the per unit? Is 117,300 divided by 11500. So that will give you how much? 1.02 per unit. That's for A. Let's see B. A distribution system operating at 12100 volt. Again, this is the actual. With the nominal base rating of 12,470. So if you see that, that is your base. And again, you are asked to calculate the per unit voltage of this distribution system. So again, the per unit is the actual divided by the base. So that will be 12,100 divided by 12,470. That's equivalent to 0.97 PU. So great. Let's move on to the next slide. So per unit system, it also consists of current, voltage, and also power, and also impedance. You have to remember, every time you calculate per unit, it always has to be actual divided by the base, regardless of the voltage, current, power, or impedance. And if you want to calculate, for example, in here, the current base, so it's the same formula as the Ohm's law, V equals to IR. But you have to make sure that the voltage is also base and the resistance is resistance or impedance is also in base. Okay, so you cannot mix. If you want to calculate I base, you cannot have V actual with the Z actual. No. Okay, that will be the I actual. Okay, it has to be in the same base. Okay, alright. So let's do the example for this one for you to understand further. Alright, so you are given V actual, you are given V base, and I actual. And then you are asked first to calculate the R base. Okay, so based on the formula, V equals to IR, remember that? Okay, so V base divided by I base. Okay, the V base is 1000 volt divided by 10 ampere, and you get that as 100 ohm. Okay, that's your R base. Okay, let's calculate your S base. So S base is a power. Okay, so means that power is V times by I, yeah, because this is base, so the voltage has to be in base and the current has to be in base as well. So you're given the V base as 1000, so 1000 times by I base is given by 10. Okay, that gives you 10 kVA. Okay, great. So you know your S base and also you know your R base. So how to calculate VPU? Okay, so remember VPU is V actual divided by V base. Okay, so the V actual is 500 divided by V base. Okay, V base is 1000. What do you get? 0.5 PU. Fantastic. Okay, so let's continue to calculate SPU and IPU. Okay, the rest. Okay, so let's continue here. Okay, next we would like to calculate, IPU. So IPU will be the same. Okay, I actual divided by I base. Okay, so I actual is given as 5 divided by 10. Okay, so you get that as 0.5 PU. Okay, you calculated IPU. So next, okay, you calculate RPU. So RPU will be R actual divided by R base. Okay, that would be, what's your R actual? Do you know your R actual? Is it given? No, it's not given. Okay, so do you know your R base? Is also not given. Okay, right. So you cannot use this formula. Instead, if you want to calculate RPU, you can use this formula. VPU divided by IPU. Because you know your VPU, you know is 0.5. And you know your IPU as 0.5 as well. So that gives you 1 PU for RPU. Okay, so next you want to calculate what is your SPU. Okay, so you're not given. Okay, so if you want to calculate using this formula, okay, divide by base unfortunately you don't know this value, right? So you cannot use this formula. Instead you use this formula because you know your VPU, you know your IPU, right? Okay, so that will give you SPU, okay, which is 0.25 PU. Yeah, okay, great. Okay, so you answer this question, you answer this question as well. Okay, so last, okay, you are asked to calculate R actual. Okay, so let's move to this empty slide. Okay, in order for you to calculate R actual, okay, R actual, you need to know the RPU, okay, times by R base. Okay, right. So we already calculate RPU as 1. Okay. Okay, RPU as 1. Alright. And then we know our R base, okay, 100 ohm. So that gives us 100. Okay, this R base, okay, we have taken from the first question just now, yeah? Alright, good. So next, okay, we want to calculate the S actual. So S actual is SPU times by S base. So SPU, it was calculated previously, and S base is also calculated previously. It's 10k VA, yeah? Remember? So you get that as 2.5k VA. Okay, so that is for 2.7 exercise.